The last section in chapter 4 is on antiderivatives. Now, the good part is we've already really looked at antiderivatives. Okay, so derivatives, obviously we've been doing, we can find the derivative of a function. The antiderivative of a function is really just going backwards. So if you want to find the antiderivative of something, okay, it's the function whose derivative is given. So now you're given the derivative and you want to go backwards. You want to say, what function has a derivative of what you're given? Okay. The application to this, which we've already done, this is where we've really seen antiderivatives, is you're given velocity and you want to find position. That's an antiderivative because you went backwards. Okay? The antiderivative is really the original. If capital F is an antiderivative of little f, then the most general antiderivative on that interval is capital F plus c. I'll talk about what the heck that's talking about. Okay, so let's come down and do a couple problems. So x squared, I want to go backwards with x squared. So x squared would be the derivative of what function? So the antiderivative of this, capital F, would be what? Well, it would be x cubed, because it would be 1 greater than this. And then you would need what in front of this? A 1/3. So when you bring the 3 down, it cancels, and I get x squared. Now, why do I have to say plus c? Because the derivative of any constant is 0. So really, the antiderivative could have any number being added over here. We don't know. So we put the plus c there. Okay. The second one. So the antiderivative of sine, go backwards. Sine would be the derivative of what? Negative cosine plus c. So if you find the derivative of this, I get sine. Okay, number 3, go backwards. 1 over x is the derivative of what? Natural log. And again, I'm going to have my plus c. Okay, and then 4. So how do you do the antiderivative of any power function? Well, what are you going to do? You're always going to add 1 now to the power and divide by that new number. So if you go back here, add 1 to 2, you get 3, you divide by 3. So it's always you divide by what your new power is. Okay? The table in your book on page 345 has a table of all antiderivatives. Okay? Like secant squared. Well, what's the antiderivative of secant squared? Tangent. So there's going to be some common ones we're going to say. Okay? Number 5, find all functions g such that g prime is that. So you're basically finding the antiderivative of this function. Okay, you're going backwards. So to do this, I'd simplify this function first. So I'm going to rewrite this as 4 sine of x plus, I'm going to actually divide them by x. Because again, I cannot do quotient rule backwards. So this would turn into 2x to the 4th minus x to the, what, 1/2 over x would be negative 1/2. Okay, all I just did was simplify this. I divided each term by x. Now I can go ahead and find the antiderivative. Okay, so the antiderivative of 4 sine would be 4 negative cosine of x plus, now what's the rule? Add 1, so it would be 5, divide by that new power, 5. So I have 2/5 x to the 5th. Okay, same thing here. Add 1, so it would be positive 1/2, divide by that power, and then add c. Okay? And then you could simplify that. I could write this term as 2x to the 1/2 here. Okay. Number 6. Find f. Find the antiderivative basically of e to the x plus 20 times 1 plus x squared to the negative 1, given that f of 0 is negative 2. So now I do the exact same thing. So go backwards. What would the antiderivative of e to the x be? Still itself. This we have to recognize. That term is the same as 20 over 1 plus x squared. And hopefully you recognize 1 plus x squared in the denominator as tan inverse. So this term would be plus 20 tan inverse of x plus c. Now because I'm given an initial condition, f of 0 is negative 2, I can find c. That's all that allows me to do. So when I plug 0 into this, I get negative 2. That's what they're telling me. So if I plug 0 in, I get negative 2, so I can solve for c. E to the 0 is 1. So I have 1 plus 0 plus c equals negative 2. So c would be negative 3. So my final equation would be e to the x plus 20 tan inverse of x minus 3. So if you're given an initial condition, you want to find c. Okay? Next one. Find f. So now they're giving you a second derivative. You have to go backwards twice. Okay? So let's see. The first derivative, if I go backwards with this, I would get what? I'd add 1, so it would be x to the third. And I would have 12 divided by 3, so 4. Plus x squared, 6 divided by 2 is 3. Minus 4x plus c. Okay? And then what? The second derivative, if I go, I'm sorry, f, I don't mean the second derivative. If I go backwards once again, then the original, so I start at the second derivative, here's the first derivative, I went backwards once, now I'm going to go backwards again, okay? And what? Add 1 to this, so it would be x to the fourth, divided by 4, they would cancel, plus x to the third, minus 2 x squared plus cx, now there would be an x here, whatever number that is, and then plus another number d. How can you find c and d? Well, I know that f of 0 is 4 and f of 1 is 1. So if I plug those in, I can actually find my c and d values. Okay? So if f of 0 is 4, so if I plug 0 into this, I get 4. That tells me d is 4 right there. Okay? So 0 plus 0 minus 0, this would all be 0. So d is 4. So now I have x to the fourth plus x cubed minus 2x squared plus cx plus 4. And now I can plug in 1 and 1. So if I plug 1 in, there's the equation, and you can solve for c, and c is negative 3. So your final equation would be, so your final f of x would be x to the fourth plus x cubed minus 2x squared minus 3x plus 4. There's the original when you started with the second derivative. You went backwards twice. That's all. Okay. 2 more. I say the graph is given, it's not. So here's a graph. Whoops. And we did this in class, guys, where you start with a function and you have to go backwards. So 2, 3, 4, 5. So let's say that's my function. Increases, decreases. Okay? So there's f. The graph of f is given. Make a sketch of an antiderivative. So that means in your head that the graph given is the derivative. This is the derivative, and you're going backwards. It's important. If you're given and you want to make a rough sketch of the antiderivative, you're going backwards. And they're telling me f of 0 is 2. So I'm starting at 2. Now what do I know? So I know from 0 to 1, the derivative is negative. So from 0 to 1 over here, this is going to be decreasing. Okay? I know from what? 1 to 3. From 1 to 3, this is positive. So over here, from 1 to 3, I'm going to be increasing. And now for concave up or concave down, I know between 1 and 2, the first derivative is increasing. Okay, so over here, I would be concave up. And then from 2 to 3, I'd be concave down because the first derivative is decreasing. So this is increasing, this is decreasing, but the whole thing's positive. So over here, I'm increasing 1 to 3. But I'm concave up, then concave down at 3. Okay, now for the rest of the time, this is below the x-axis, the derivative, so over here I must be decreasing, okay? And this goes from decreasing to increasing. So over here, I must be what? Concave down till 4, then concave up. Okay, so I started with a function that's actually the derivative, and I sketched the original. So this is the derivative of this. Okay, we'll do more practice of those. And then the last one, a particle moves in a straight line. You're given its acceleration. Its initial velocity is -6 centimeters per second, and its initial displacement is 9 centimeters. Find the position function. So I'm starting with acceleration, and I want to go all the way back to position. So first I can find velocity. From acceleration, find the antiderivative of that, which would be what? 3t squared plus 4t plus c. Okay? And I know right here it tells me v of 0 is -6. So I know when I plug 0 in, I get -6. Okay? Right there it says v of 0 is -6. So when I plug 0 in, how do I get -6? So this would be what? 0 plus c equals -6. So c is -6. So I have 3t squared plus 4t minus 6. Now I can find position. Go backwards once more, which we usually use s, which would be what? T cubed divided by 3 would just be 1t cubed plus 2t squared minus 6t plus d. How do you find d? The initial position is 9, so d is 9, plus 2t squared minus 6t plus 9. So there it is. This is the most common application we're going to do with antiderivatives. You're going to be asked to just find antiderivatives. You're going to be asked to sketch antiderivatives, and you're going to be asked to do particle problems where you're given either velocity or acceleration and you have to go backwards.